Welcome to Data Games. This is a teacher introduction to a game called Cartweight. Cartweight is a good starter game. It can be an introduction to linear functions, or it can act as a review. It deals with slope and intercept, graphs, and multiple representations. This video assumes you've watched the student videos and have tried playing the game. Here we'll talk about the underlying mathematics and some game details. The basic idea is that you have a cart with a bunch of bricks on it, and you're supposed to guess the weight of the cart with the bricks. The total weight is the weight of the bricks plus the weight of the empty cart. And the weight of the bricks is the weight of each brick times the number of bricks. This equation maps directly onto slope-intercept form, but with different variable names than the students may be used to. Furthermore, the slope and intercept have meaning. They're the weight of a single brick and the weight of the empty cart. All of this is what we hope students will figure out for themselves. Your job is to help them stay on course, to check for understanding, and to ask sneaky leading questions where it's appropriate. For most students, the graph is the key. Let's see how that works in the third level, Davenport. I'm going to click on this Levels button. I can see I need certain scores to move up. Here's the top secret shortcut. I hold down Alt or Option plus Shift on the keyboard and click on this red dot. I immediately start a Davenport game, and a new cart shows up with 4 bricks. I clear my old data. Now, suppose I thought the bricks were 3 each. I type in 12 and check the weight. I find out the actual weight is 37. Wow, I was off by a lot. Now I get a new cart and I see 18 bricks. I might think 18 bricks is supposed to be like 60, but I was off by a lot, so I'll try 100. I check the weight and see that in fact it's 107. It's kind of close. I got 35 points, but that's not good enough if I want to move up. This is the point where we want students to use a graph to really see the data. When my movable line lines up pretty well with the points, I have a model, and I get an equation for the weight in terms of the number of bricks. When I get the next cart and I see there are 6 bricks, I can just use this formula. 6 times 4.99 is 29.94, plus 17 is 46.94. So I type in 46.94 and check the weight, and sure enough, the actual weight was 47. It's really close, gives us 99 more points. That's more like it. Students can use this technique to make good predictions and win the level. But in fact, many students are reluctant to use the graph. It also may be reluctance to use a formula, but that's one of the points of this activity, to get students to be willing to use a graph as a tool. Another problem students sometimes have is looking at this formula and recognizing it as slope-intercept form. It doesn't have x and y. But students need experience with other variable names, so ask explicitly, in this equation, what's the slope of the line? You want them to say 4.99. Another issue is with rounding. We're experienced enough to recognize that 4.99 probably means exactly 5, but students will often calculate out to many decimal places. It's an interesting question. When is the right time to round? You might ask students that and see what they say. The real payoff comes when you ask, what does the slope mean? How about the intercept? Here, if this is exactly 5, and it really is, we might recognize that 5 is the weight of each brick and 17 is the weight of the cart. That's a very hard thing for students to understand. It will take multiple applications in different contexts for them to get it, but this game can be one of them. Let me give you a brief tour of the levels. The first level, Dubuque, has no intercept, and every time through the game, the bricks each weigh 3. So students get an early, quick success experience and learn the game mechanics. This level could even be a homework assignment. The next level, Ames, the intercept is 8 and the slope is 4. Every time you play the game, they have the same values. So by playing it over and over again, you can gradually figure out what these magic numbers are by trial and error. But Davenport, the third level, actually requires modeling. Every time you play the game, that is every 5 carts, the slope and intercept change. Students get frustrated with this at first, but some will soon figure out that you have to take the first 2 points and use those to determine a line. Then you can use the next 3 cards to get the score you need to unlock Urbandale. Unlocking Urbandale is a good goal for an Algebra 1 class. Urbandale is like Davenport, except that the slope and intercept are no longer whole numbers. Up to now, we've been working only with integers. In the next level, Waterloo, the individual bricks have a little bit of variation in them, so things don't line up perfectly. This may be suitable for a stat class or for students who are moving a little faster. When you go further into Minot, you'll oh no, there are 2 sizes of bricks. This is more of an Algebra 2 sort of thing. Have a good time. Good luck.